In this video, we'll explore the use of the Arc Rotate camera to be used for a product visualization demo. This mockup website is a great example of how you can implement Babylon into an e-commerce website that wants to display their products in 3D. We'll learn how to properly set up the camera to smoothly rotate around a 3D object using various camera behaviors, as well as preventing clipping issues. So let's get started. Let's take a look at our starting scene. So in this starting scene, we have a product preview. This is a mock-up page of what this would look like if I was creating a product display on a website. So here we have a 3D preview of the watch. I can navigate around. I'm using a free camera for this. I can take a look at this. I can get in quite close and take a look at all the details. This is a very realistic looking pocket watch. This comes from Polyhaven along with the background. The background is a blurred out environment texture that was created from an HDRI that I took off Polyhaven as well. So before we take a look at the code, let's take a look at where those resources are found. So here we have the Polyhaven site. This has the 3D model. It is the vintage pocket watch by Tal Swicegood. This is the pocket watch we're going to be using as our product. And on Polyhaven as well, under the HDRI section, we have this HDRI called Christmas Photo Studio 01. Now, I want to use this HDRI because it has some really nice warm colors. And I think this really helps to kind of make the gold of the golden watch stand out a bit more. So with that said, let's take a look at our first issue with our product display as is. So if I take a look around in here, I can move around just fine, but I'm using a free camera. A free camera is not going to be ideal for something like this. If I want to take a look at this watch, I don't want to have to move around so much just to take a look at the details. The free camera is better for maybe a walk around in a architectural environment. So if I'm walking around a house or an apartment or some sort of environment like that, a free camera would work just fine. Same thing if I want to navigate around a larger environment, I would use a free camera. But for a product display where we're just looking at one object, I would want to use an Arc Rotate camera. So let's jump into the code and let's take a look at how we can modify that. Okay, going back into Visual Studio Code, before we take a look at modifying the code for the camera, let's first go over what we have so far. I have a class called Camera Mechanics. Again, you'll find a snippet to the starting code that I'm using here in a folder called Snippets Camera Demo. So it has everything that we have so far right now. And again, you'll find a link to this code repository in the description down below. The other assets I've included as well include a new environment texture called Xmas_BG. So that's being utilized in here, right here. And then we also have a new model called VintageWatch.gob. Everything that's included with this class has been covered in previous videos. So how to create the environment texture, how to import models, things of that sort. So with that said, let's go down into our create camera method. Right now we're using a free camera. I want to swap that out with a different type of camera. Let's take all this right here and we're just going to delete it. Now, I am going to be using a camera that is a global variable. So let's add this at the very top. And the camera that we're going to be using is called a Arc Rotate camera. So type in Arc and then look for the Arc Rotate camera. Okay, make sure that gets imported in. So Arc Rotate camera at the very top here. We're no longer using the free camera up here. We are going to be using the Vector 3 in a moment. All right, let's jump down into our camera method. I'll say this.camera equals new Arc Rotate camera. We'll give it a name of camera. Now the next two values, the alpha and the beta, we're going to set to 0 to start off with. We are going to be modifying these in a moment. So we'll leave these at 0 for now. Next we have the radius, which as you can see there defines the camera distance from the target. So I'll leave that at 5. Next we have the target. The target is a vector 3, so we can either use the position of, say, the watch or any other mesh object, or it can also be a point in space. I want to start off by pointing this at the center point of our world. We'll say vector 3 dot 0. You know, we're not using new vector 3, just vector 3 dot 0. Next, we need to add this to our scene, so this dot scene, and that's it. Below that, let's also ensure that we can actually move around with our camera. So we're going to say this.camera.attach control. And we're going to say that we want to use the DOM element of this.canvas. That's what we're going to be using for controlling the camera. And the next element is that we want to use prevent default. So no prevent default. We'll set that to true. There is going to be a few other options we're going to be working with in the attach control. For now, we're just going to leave that as is. Okay, let's save this and let's see what we have so far. It looks like our camera is actually looking down on the watch. And if you take a close look, we can see that the face of the watch, the glass portion, is actually pointing towards the left. If I rotate this, say 90 degrees to the right, so I'm just going to left click and pull to the right. Okay, so we want to rotate it like this and then rotate it up like that. Now note, we're not actually rotating the object, we're rotating the camera around the object. So we're starting off like this. I know I need to rotate 90 degrees this way and 90 degrees this way. That's going to be the alpha and the beta values that we set to 0. To better understand what these values are and how they operate with the arc rotate camera, we're going to go into the documentation. Babylon does have a great image that will help us to better understand how this works. Okay, so in the arc rotate camera section, there is an image here that displays the alpha and the beta. So the beta is essentially the rotation that's going up and down the vertical axis, and the alpha is horizontal left and right. If you take a close look at the numbers on the rings here, so beta at 0 starts off right here. If we go back down this way 90 degrees, it's a little bit hard to see probably in the video, but you'll see that it has a pi symbol divided by 2. That's essentially 90 degrees. Same thing going forward. We have the alpha and the beta, pi divided by 2. Now do note, if we take a look down here, it says beta increases in the clockwise direction, while alpha increases in the counterclockwise direction. What that typically means is that if this is 90 degrees, this would be a negative 90 degrees and vice versa. To jump back into our code, let's modify the alpha and the beta values. Going back into the arc rotate camera, we have the alpha and the beta values. With the alpha, we want to modify this so we rotate it 90 degrees. We're going to do the same thing with the beta, but let's just start off with the alpha first. Now, if you remember from the image, we're using pi. So to use that, we're going to use math.pi. Math.pi is essentially 180 degrees in this sense, and we want to divide that by 2. This will give us 90 degrees. So we'll save this and we'll take a look at what that does with our camera. Okay, so it does look like it did rotate 90 degrees. Let's go and pull up a bit, and no, not really. So it did rotate 90 degrees, but as you can see here, it's pointing in the wrong direction. So we need to rotate this negative 90 degrees, not positive 90 degrees. So we want this to be rotated in the opposite direction like this. All right, let's also modify the rotation for the beta. So the beta is the rotation going up and down like this. We know that needs to be 90 degrees as well. So going back into the arc rotate camera, to use negative 90 degrees, all we have to do is add in a minus symbol in front of the math.pi divided by 2. I know that the 90 degrees has to be applied to the beta as well. So let's add that in here, math.pi divided by 2. We'll save that. And note, this one's negative, this one is positive. Just like I mentioned before, one goes clockwise, one goes counterclockwise. Okay, there we go. So far, so good. Now we have the camera pointing in the correct direction. I can rotate around just fine. So again, left click to drag and move this left and right and up and down. So we have our camera situated and orientated correctly. Well, let's try to take a close look at some of the details of this pocket watch. I use my mouse wheel to scroll in, and you can see it's very frustrating. We can't actually zoom in slow enough to actually take a look at the finer details of this watch because it goes way, way too fast. We need to modify that speed of the zooming. So let's go into our code. Let's take a look at how we can modify that. Okay, back into our create camera method. Right below the attach control, I'm going to add in a new property, this.camera.wheel precision. So wheel precision will allow us to adjust how quickly we zoom in and out using our scroll wheel. And for this, you actually need to set this to a pretty high value. So I'm going to go with a value of 100. We'll save that real quick. And let's take a look at how that modifies the zoom speed. Okay, so I'm going to use my mouse wheel. And there we go. You can see it's a lot slower. It's now getting quite close. You can see there is some clipping. We're going to adjust that in a moment. But I can get close enough to actually look at the surface details of this watch. I'll reload this page real quick. You'll notice that I'm using the default loading page from BabylonJS. That's perfectly fine. But you'll notice that the camera is a little bit too far away from the object. I want to adjust the radius so that the camera is a little bit closer to the pocket watch, so we start off with a much bigger view overall. So back in the arc rotate camera, the radius is set to 5. Let's bump that down just to about 4. I think that'll be fine for this. Okay, that looks a little bit better. You may want to bump it down to 3 or even down to 2.5, depending on what object that you're looking at. Okay, so let's take a look at one other thing that we can modify. You'll see that I can get in pretty close, but once I get in too close, let's say I want to look at the numbers or the detail on the ornamentation here, you can see that we start getting into something known as clipping. So clipping happens because of the near and far planes of the camera. To understand how the near and far clipping planes of a camera actually look, I'm going to use this visualization. So we have an image up here. Okay, so this is an image that I found online. This demonstrates how the viewing frustum and the clipping planes work with a camera in 3D space. So here we have the cone. This determines what gets rendered on our screen. There's no point in rendering out objects that appear off the side here or behind the camera. That's not really good for performance or in general. So we only render things that get viewed within this cone. Now we can also adjust the clipping planes. That determines what also gets rendered. So looking at this image, if there was a sphere right here in between the near clip plane and the viewpoint or the camera here, that would actually not get rendered. That's what's happening in our scene in BabylonJS. We're mostly concerned with the near clipping plane because that determines how close we can get to an object. If you're working with a much larger scene, you may want to adjust the far clip plane. Now do note, if you adjust these planes, they are going to affect performance because now you're determining how many more objects can be rendered on screen. So if you have a lot of small objects that will appear close to the camera, now more of those objects can be rendered because of the clipping plane that you adjusted. Let's go back into our code and let's modify the value that we're using for the near clipping plane. Going back into the create camera method, again below the camera wheel precision, we're going to add in the min z. So in BabylonJS, I don't believe they use the clipping plane terminology. So in BabylonJS, it's just called min and max z. For the near clipping plane, that is going to be the this.camera.min z. And we'll set that down to a pretty low value. Let's just start off with a 0.3. And if need be, we can reduce this even further. I'm not going to be modifying the far clipping plane because I can see just one object in my scene. If for whatever reason we had multiple objects off in a distance that were being clipped away, then I would adjust the max z. So with a value of 0.3 for our min z, let's see if this clears up the issues with our clipping plane. Okay, so let's zoom in and see how close we can get before we start clipping. So far, so good. You can see I can almost basically touch the object. So 0.3 will work just fine. I can see all these surface imperfections of the watch. I can see all the detail. Now do note, just because we adjust the clipping plane doesn't mean that we won't clip at all. If I keep zooming in, you can see I can get inside of the object. If I was using this as a product preview, that would look a little bit unprofessional. I wouldn't want to have that kind of feature enabled. So we need to adjust another property of our camera, and this is going to be the radius limits for both the how close we can get to an object and also how far away we can get to an object. Right now I can also zoom out, and there is no limit on how far I can zoom out. Obviously, if I'm using this as a product preview, I would not want to zoom out this far. There's really no point in doing that. So we want to adjust the radius limits. Again, this has nothing to do with the clipping planes. Depending on what you set your radius limits to, you may not even need to adjust the min and max z of the camera. I'm just going to leave that in there for now anyways. But let's adjust the lower radius and the upper radius as well. So we're going to say this, dot camera, dot, let's start off with the lower radius limit. And we'll use 2 for the value for the lower radius limit. For the upper radius limit, let's go with a value of, let's go with 10. Okay, we'll save that and let's see how that works with our watch. Okay, let's test out the radius limits. I'm going to zoom in. Okay, that's as far as I can go. I cannot get any closer than that. So the min z of the camera is not even being utilized yet. All right, let's zoom out. Let's see how far we can zoom out. And I think for a value of 10, that might be a little bit high. We can adjust that in a moment. Now, there is going to be one other thing that we can modify with a product preview, and that is the ability to pan. If I use my control key on my keyboard and left click, I can move left and right, up and down. I can also use my right click. So holding down right click on your mouse will allow you to do that as well. For a product preview like this, I may not want to have panning. As you can see, I can move this off screen and no longer see it. I don't want that. So I want to be able to disable the panning. Now, you can't actually disable panning. You can only adjust the sensitivity, but we can kind of disable it by adjusting the sensitivity all the way down to 0. So let's jump back into our code and let's modify the panning sensibility. Okay, going back into our code, we can adjust the panning sensibility. We'll set it to this.camera.panning sensibility. And this is kind of like the sensitivity of the panning, but I'm just going to set this down to 0, and this will basically disable the panning in our camera. Again, this is all personal preference. If you want to keep panning with your camera, feel free to do so. Now, one other thing I want to take a look at, and this goes hand in hand with the radius limits, is something called a bouncing behavior. Right now, if we go back into our scene, once I get too close, you can see it automatically stops. Same thing if I zoom out too much, it automatically stops. You can also add in a new behavior, which allows you to create kind of like a bounce back effect. If you get too close or too far away, once you hit your radius limits, you can use this bouncing behavior. So I'm not going to be using it for this product, but I do want to go over how you can utilize it. We'll be using the default settings for this. So let's take a look at the code and how we can implement this. Going back into our code, we're now going to be looking at using camera behaviors. So the bouncing behavior is a camera behavior. We're going to say this.camera.use, and we have the use bouncing behavior. This is a Boolean, so I'll set this to true. Okay, that will allow us to create that bouncing behavior with the camera. And while we're here, let's also go back and let's adjust the lower radius and the upper radius limits. I'll set this down to 1 so we can get in a little bit closer. For the upper radius limit, I'll decrease this down to 5. All right, so if we zoom in too much, you can see it creates this bounce effect. I'm not really a big fan of the bounce effect for this kind of scenario. If this is more of a professional product display, I wouldn't want to have any kind of weird animations like this. It just doesn't really fit for this type of product. So I'm not going to be using this for this product, but I did want to go over how to utilize this. So again, this comes into play whenever you reach either of the radius limits. So getting too close or too far away. Let's take a look at some of the other behaviors we have available to us with the camera. Going back into our code, I'm going to take this guy right here, the use bouncing behavior, and I'm just going to comment it out. I'll leave it in the code, but I'm not going to be using it. Let's add in the next one. So this.camera.use, and we're going to be using the rotation behavior. This allows us to create a rotating camera. And I'll set this to true. We are going to be adding to this in a moment. Let's just take a look at what the defaults give us. Okay, and as you can see here, now we see the camera slowly rotating around our object. I think this looks good with this kind of product display. We slowly see the object from different angles. I can click in here, it'll stop the rotation for a moment, so about 1.5 seconds, and then resume back to rotating. I can still navigate around and take a look at this from all different angles. And depending on where I'm at, let's say I stop right here, it'll then continue rotating from this angle. Okay, so the defaults for the auto rotation are fine, but we can modify them so we can make this move a lot faster. We can also adjust the different timings of this. So right now, if I left click in here, there is a 1.5 second delay before it actually starts up again. We can modify that to whatever time we want. And there is also a spin up timer. So the spin up timer determines how quickly this will get up to speed. That's used in conjunction with the rotation speed. Let's take a look at how we can modify those properties. Okay, to modify these properties of the auto rotation behavior, right below where we declared it, we'll say this.camera.auto rotation behavior dot, and we'll see auto rotation speed, rotation spin up time, and wait time. Let's start off with the rotation speed. If I hover over this, you'll see that this is a number type, but it doesn't really tell us what this number represents. The number is actually radians per second. So we can use a fairly small value for this, and it will spin quite quickly. Even a value of 1 will be fairly quick. Let's take a look at what this does. Okay, so with a value of 1, you can see it's moving a lot quicker. For a product display like this, you may not want to have it spin this quickly, but I'm using some exaggerated numbers here just so we can clearly see how all of these things work. Okay, jumping back into our code, again, down below where we created the rotation speed, to also add in the other properties. So we're going to have the spin up time and the wait time. Both of these are millisecond type values. Now, the value for the spin up time determines how quickly it'll spin up to the desired rotation speed of 1. I'll set this up pretty high, up to 4,000. 4,000, again, that is in milliseconds. So 4,000 milliseconds will equal 4 seconds. That means it's going to take 4 seconds to go from 0 back up to 1 for the rotation speed. The other value is this dot camera dot auto rotation behavior, and we have the wait time. The wait time determines how quickly we go from, say, interacting with the object and stopping the animation to going back into starting the rotation again. So again, this is also in milliseconds. And for this, I'll set this to 4,000 as well. So we're going to wait 4 seconds after we interact with the scene for it to start the rotation again. Okay, so there we go. The camera is rotating around the watch. I'm going to left click in here. Now we're going to wait 4 seconds, and then we're going to have a 4-second spin up time. So it slowly starts up. You can think of this kind of like a helicopter where it's slowly spinning up to get to its speed. And again, if I left click in here, it'll repeat that process. Now there is one other issue with this. Right now, if I left click in here, I can stop the animation. But what happens if I want to zoom in on the object and take a look at something on the front of the watch? Well, as you can see, the rotation is still happening. We need to enable the rotation to stop if I were to zoom in on the watch. So if I start zooming, I want to stop the animation similar to how I would stop the animation if I left click in here. Let's take a look at how we can modify that in the code. Let's go below the wait time. I'll say this dot camera dot auto rotation behavior dot zoom stops animation. Zoom stops animation is a Boolean. So we're going to set that to true. And once again, we'll take a look at how this works. Okay, so I'm going to start zooming in. And there we go. You can see it stops. And it's going to work the same way as before if I were to left click on the canvas. Okay, so now let's take a look at one last behavior on the camera. That's going to be the framing behavior. To really understand how this framing behavior is going to work, I'm going to turn off the auto rotation behavior. I'll leave it in the code, but I'm just going to comment it out. So the framing behavior works off a mesh. It uses the bounds of that mesh to determine how we're going to be looking at that mesh. So it's going to zoom the camera in to the bounds of that object. To demonstrate how this works, I want to visualize the bounds of this mesh, but you will see there are going to be a few issues. Let's just start off with the basics and let's enable the framing behavior. So I'm going to use the framing behavior, and it's used in the same way as before, and I'll set that to true. Going back into our scene, you'll notice that it didn't really do anything. The way this works is that we need a target. It is a mesh type. This mesh has bounds to it. So right now the target of the camera is not set to the watch, but it's set to the center point of the world, which is vector 3.0. So we need to update the target of the camera to be the watch. There are going to be a few issues with this, but we're going to troubleshoot this as we go along. Okay, going back into our code, going back up to the arc rotate camera, the target right now is vector 3.0. This is not a mesh. I want to update the target to be the watch. So the way that we would do that is right after we create the framing behavior, I'm going to set the target to be the watch. We can also do this in here as well. So just to ensure that we don't have any weird timing issues, what I'm going to do is after we create the watch, then I'm going to set the camera's target to be that watch. So we'll do this in here instead. I'll say this dot camera dot set target. Now notice there is two different types of ways of setting a target in here. So this dot camera dot target is a vector 3. We don't want that. We want to use the mesh. So I'm going to say this dot camera dot set target, and this allows us to take in a mesh. We can also use a vector 3, but since we already have the mesh of the watch, I'll use that. I'll say this dot watch. Okay, and as you can see there, the framing behavior is now working as intended, but obviously we're way too close to this object. Now, the reason why this happens is because we're now using the bounds of a object in here that is very, very small. So the camera zooms in until it fits the bounds of that object. To visualize the bounds, let's go back into our code and let's enable the showing of those bounds on these mesh objects. What I'll do in here is actually console out the meshes. I'll say console.log meshes, meshes, and we'll take a look at the mesh that we can utilize. Okay, let's take a look at the inspector. I'm going to open up the console. Okay, so we're using the meshes 0 as our target. This is the root, so we don't want to use this as our target. We want to use something else in here. Now we can use that as our target, but since we're using the framing behavior, it's going to be using the bounds of that mesh. So the root does not have that. If we take a look at these others in here, like this vintage pocket watch primitive 0, this would have bounds. So we can reference any of these in here, 1, 2, and 3. I want to visualize the bounds in my code, and then we can see whether or not we can use those bounds with this watch. Okay, going back into our code, we need to enable the showing of those bounds for all the other meshes that we looked at. I'll be using the this.watch as meshes 0, plus visualize the bounds for the other meshes in there. I'll say meshes 1 dot show bounding box. Okay, that is going to be a Boolean. So I'll set that to true. I'll just copy this, duplicate it a few more times. Okay, 2 and then 3. For now, I'm just going to turn off the framing behavior just so we can clearly see the bounds. I'll save that real quick. Okay, so looking at the watch here, I know I want to use the bounds for this outer piece. I don't want to use the face right here or the inner portion of that face. Those are too small. So we want to use one of these as our target instead because we are using framing. Let's go back into our code and let's update the target and let's turn on the framing once again. Okay, back in our code, I'm going to uncomment out the framing behavior. So we'll set that to true again. And I believe this is the largest bounding box. So we can use this as our target. And even if you use any of these others in here, I'll show you how you can modify the framing behavior further. So instead of using this.watch, which is the root as our target, I use meshes 3. So I'll just copy that there and we'll place it in there. Now set target requires a vector 3 or an abstract mesh. And meshes 3 is going to be an abstract mesh, which works just fine. We'll save this once again and let's take a look at this. Okay, so much better. We are still too close, but we're no longer going through the watch itself. So now I want to push this out a bit and stop it right about here. Let's go back and let's take a look at how we can modify the framing behavior now. Okay, going back into our code, now let's go down and let's modify the framing behavior radius scale. So this.camera.framing behavior.radius scale. And let's start this off with a fairly high value of 3. And we can come back and modify this as need be. Okay, so that's looking a little bit better. We're a little bit further out. We could probably bump that out to maybe 8 so we can actually see the entire thing. And let's also turn off the bounding box from being visible. Okay, let's adjust the radius scale. Let's go and bump that up to 8. Let's go down into our create watch. I no longer need to show the bounding boxes, so I'm going to comment that out. And same thing for the console.log there. Okay, so let's go and save this and let's see what we have so far. Okay, so I'm going to refresh this real quick. And you can see we have almost the opposite effect now. So we have this effect where we're actually pulling out away from the watch. That's because the radius scale of the framing behavior is higher than the radius scale or the radius of the actual camera itself. The radius scale of the framing behavior is currently set to 8, whereas the radius of the camera is set to 4. So one is higher than the other, causing the framing behavior to operate in the opposite direction. We can also mix these up a bit. So if you want to create a really cool zooming effect, you can increase the radius of the camera and then decrease the radius of the framing behavior. Let's take a look at how we can modify that. So just for testing purposes, I'm going to bring down the radius scale down to say, let's go with 2. And let's go up to the very top here. In the arc rotate camera, by default, the radius right now is set to 4. Let's bump that up to 40. Okay, so now the camera is very far away from the object, in this case, vector 3.0. But the radius scale of the framing behavior is going to zoom in all the way until we hit this radius of 2 for the framing behavior. Okay, so much different overall. So we can adjust the framing time if you want that to be quicker or slower. Go back to our code, let's modify that. So right below the radius scale, we're going to say this.camera.framing behavior.framing time. This is also set in milliseconds. So I can set this to a value of 4,000. Again, that's 4 seconds. And there is our slow zoom. Okay, I can still interact with this just like before. You'll notice that if I go below the watch, it'll automatically rotate itself. This only happens if you go below. So this is useful if you have some sort of, say, architectural rendering and you don't want to go below the ground, it'll automatically rotate itself. Okay, let's turn on the auto rotation behavior and let's modify those settings so we have something a bit more realistic. And then we're going to finish this off. Okay, so going back to the code, I want to use the framing behavior in conjunction with the auto rotation. I'm not going to be using the bouncing behavior. So let's turn this back on. I don't want the rotation speed to be this high. I'll bump this down to say maybe 0.75, maybe even lower than that, maybe down to 0.5. The rotation spin up time, we'll set this down to a value of 1 second, so 1000 milliseconds. And the rotation wait time, we'll leave this at 2 seconds. We'll leave everything else as is. We'll save this and we'll take a look at our final scene. Okay, nice slow animation. That even looks scripted right there, where it actually looks like it zooms in right at the time where we want to see that engraving on the back there. And this looks pretty good. We can zoom out, we can still navigate around, but we have a nice little animation of this object. So there you have it. That's how you modify a camera to be used as a product display camera.